Welcome back to Mathematics Lifeline. In today's video, I want to talk about absolute value inequalities and discuss the strategy that we need to actually solve these absolute values, inequalities that is. Now, absolute value inequalities are tricky because we actually have to split into a couple cases. And the reason for that is because of how the absolute value is defined. So this is called the absolute value of x. That's what these two bars around x mean. And now there's two cases for this. So it's either going to be just whatever number x is as long as x is positive. So if x is a positive number, it's just going to spit out whatever the number is on the inside of the absolute value. So as an example, the absolute value of 4, well, since 4 is a positive number, it's just going to spit out 4, right? It's going to give you the number right back out of the absolute value. Now, the other case is if x is a negative number. So that's saying if x is less than 0. So that means this x right here. Now, if x is less than 0, then what the absolute value does is it makes it negative. But the reasoning behind that is if you have a negative number and you make it negative again, it turns positive. So as an example, if I took the absolute value of negative 3, well, by definition, I need to put a negative out in front of that number. So it's negative 3. And now I have two negatives being multiplied, so that cancels out to a positive. So I get a positive 3 out of it. So this is how the absolute value is defined. You can see that there's two cases that we have to consider whether x is positive or negative. And that affects how we have to solve these absolute value inequalities. Because whenever we do split into two cases, one of them has to be negative on the right side or on one side of the equation because of the way that it's defined, since we have these two possibilities. So let's look at example 1. This one is the absolute value of x is less than or equal to 3. So again, we are going to have two cases here. The first one is always going to be treat it like the absolute value isn't even there, right? That's always going to be your first case. We'll just be, let's get rid of the absolute value and say that's less than or equal to 3. Now the other case is going to be this has to be turned negative. So we're going to have x and we're going to have negative 3. And again, this comes from we need this negative in the other case. But remember, when you multiply on one side of an equation by negative with an absolute value, you actually have to flip the inequality. So because this side became negative, we have to flip the direction. So this is going to become greater than or equal to negative 3. Now, one thing I want to point out is there's a distinction with the wording for these cases. So we have two answers here. The question is, do we need to use the word or and in between them? And when we have these absolute value inequalities, if we have a less than symbol, it doesn't matter that it's less than or equal to, just less than in general, we're going to use and. So this will be, my two solutions are x is less than 3 and x is greater than or equal to negative 3. If it was greater than or equal to right here, or just greater than, it would be an or. And we'll see a case of that in a second. So on a number line, we kind of can plot out what we have here. So let's say here's negative 3 and here's positive 3. We know that our solution set is when x is less than or equal to 3. So that's everything to the left of 3. And x has to be greater than or equal to negative 3. So because it's an and, you have to include both of these regions. Or the regions have to kind of overlap each other. And so the only place that happens is right in here. So this would be your solution set, or in interval notation, it would be denoted as negative 3 to 3. All right, so there's a lot of ways to represent your solutions. We have this algebraic way, we have the number line, and we have interval notation. But yeah, this is the end of the first example. Let's go ahead and move on to another little bit trickier one. All right, so here we have example 2. So this one is the absolute value of 4x minus 3 is greater than 5. So again, when we solve these inequalities, we need to remember that there's two cases. The first one, we kind of get rid of the absolute value. We treat it like it's not even there. So it'll be 4x minus 3 is greater than 5. Now remember I said if the difference between or and relies on what this sign is. So since it's a greater than sign, we're actually going to choose or as the word that's in between the two cases. And then the last case, we have to make the 5 negative. But remember, when we make the 5 negative, we have to flip the inequality. So we're going to have 4x minus 3. Instead of it being greater than, it's going to be less than, and it'll be negative 5. Okay, So these are our two possibilities. Now what we want to do is get our solution for x. So we need to solve these equations, or inequalities. So the first thing we want to do is add 3. So we're going to add 3 here. The same thing on this side. We'll kind of work them at the same time. So we'll add 3 to both sides. So what happens is these are going to cancel, and we're going to get 4x is greater than 8 on this side. Or on this side, we're going to get 4x is less than negative 5 plus 3 is going to be negative 2. Right? And then to solve my inequalities for x, I need to divide by 4 on both sides for both of these equations. So I'll divide by 4 here, divide by 4 here. So then this side, the 4's will cancel, and we'll get x is greater than 8 over 4, but 8 divided by 4 is just 2. And then I have or, on this side, the 4's cancel, and I just get x is less than negative 2 over 4 is the same thing as negative 1 over 2. So negative 1 half. Okay, so these are my two solutions. So I have either x is greater than 2 or x has to be less than negative 1 half. Right, and we can always, with these answers that we get, you can write them in interval notation. You could do it on the number line. It's just however they're asked to be written. But let's go ahead and just check a few possibilities to make sure that what we're saying is even true. Right, so if I say x is greater than 2, I can choose any number to the right of 2. So let's say I choose 4 as an example. So if I plug 4 into my x, I want to make sure that this side is greater than 5. So 4 times 4, plugging in here, gives me 16, and then minus 3 is 13. And so I have the absolute value of 13, and I want to know, is that greater than 5? Well, using this definition that we have, because 13 is positive, this gives me a positive 13 out, right? And we know that 13 is a bigger number than 5, and so that will hold if x is greater than 2. Now let's try x is less than negative 1 half. Let's go ahead and try that one out. So if I choose, let's say, negative 2 as an example, right, because it is less than negative 1 half, so all I have to do is test one point. If I plug negative 2 into this, I'll have 4 times negative 2, which is negative 8. And if I subtract 3 more, I get negative 11. So I have the absolute value of negative 11, and I want to see, is that greater than 5? Well, let's see. I have a negative number on the inside. So I want to use this case, which means that the absolute value is negative 11, which turns positive, and it'll be a positive 11. And 11 is greater than 5. So we know that that solution set holds as well. So we're confident in our solutions. Everything that we tested worked out, and this will be our answer here. Now remember, we need the or just because we started out with a greater than. If it was less than, then it would be and. All right, so that's the end of example number 2. Let's move on to example number 3. All right, so here we have example number 3. This one is the absolute value of 3x plus 6 is less than 4. Okay, so we now know the strategy to solve these. So I want you guys to go ahead and try to solve this if you can, and then come back here and we'll do it together. So hopefully you were able to pause and get this one done, and I'll go ahead and go through the solution right now. So we have the absolute value of 3x plus 6 is less than 4. So automatically we have a less than. We know that we're going to have and in between our cases. Okay, so the one case, we just treat it like the absolute values aren't even there. So 3x plus 6 is less than 4. And now we are going to still have 3x plus 6. But remember, we have to multiply this side by a negative. So the inequality has to flip and will become greater than. And then this one will be a negative 4. Okay, and then now we just have two equations to solve. So with this one, we're going to subtract off 6 on both sides. Same thing over here. So these cancel, and I get 3x is less than 4 minus 6 is negative 2. And on this side, these cancel, and I get 3x is greater than negative 4 minus 6 is negative 10. And then now the last thing I need to get my solution for x is to divide all the sides by 3. So I do this here, I do it here. So these cancel. I get x is less than negative 2 over 3. And this side, these will cancel, and I get x is greater than negative 10 over 3. All right? So this is my answer. So x has to be less than negative 2 over 3, and it has to be greater than negative 10 over 3. And again, I'll show what we're looking at on the number line here. So if we make a number line, this side we'll say this is negative 10 over 3. And we'll say this is negative 2 over 3. So I know x has to be less than negative 2 over 3, right? So it's gonna be an open circle here because it's not going to be equal there, but it's going to go this way. And it will technically keep going, but because we know x also has to be greater than negative 10 over 3, it actually will stop right there, right? So it's just the region that's in between those two, and that's just because it's an and, right? So that's why it's important to put an and, is because if we didn't, then this would just extend all the way to the left, and it's not actually true if I go that far, right? So we have to make sure that the and the or is put in the right spot. All right, so that was example number 3. We're going to go ahead and do example number 4. Now, this one is going to be a little bit trickier, but I think we can get through it. So example 4 is right now. All right, let's go ahead and start on example number 4. So this is going to be the last one for this video. This one kind of ramps it up a little bit because now on the right side we have an expression with x, right? So this does change just a little bit. So you can go ahead and try it, and I will go ahead and get started on the solution. Okay, so the first thing that we see is that we have less than or equal to. So that's going to tell me I'm going to have an and on the inside. Now, again, my cases, I'm going to treat them exactly like normal. So I have, just like there's no absolute value here, so 3x plus 17 is less than or equal to 2x minus 6. Let me move this over. And now the other case, I need to make the right side negative and flip the inequality. So I'll have 3x plus 17. So I flip the inequality. It'll become greater than or equal to. And then on this side, I have to make the entire thing negative. So it's going to be negative 2x minus 6. Okay, so it gets a little trickier because we actually do have to distribute something on that side. And all the steps aren't going to be algebraically the same, right? On the last one, we were able to kind of do the same things. But with this one, because of that expression on the right side, it changes things up a little bit. But this side we can solve just like a normal equation. Same on this side as well, but we'll start with this one. So we want to get all the x's to one side and all the numbers to the other. So what I'm going to do is I'm going to subtract 2x because I want to get it off the right side. So now 3x minus 2x is going to give me just 1x. I still have plus 17, and it's less than or equal to negative 6, right? Because these will cancel at that point. And then to solve for x, all I need to do is subtract 17 from both sides. So minus 17. And I get x is less than or equal to negative 6 minus 17 is negative 23. Then I have and now I want to try to solve this side. So what I'm going to do is I'm going to distribute that negative that we have on the right. So if I distribute a negative, I get negative 2x, and then I get a plus 6. Okay? And then now it's the same kind of thing. We want to get the x's on one side, the numbers on the other. So I'm going to add 2x to this side. So this gives me a 5x right here, plus 17 is greater than or equal to 6. Now I want to subtract 17, so minus 17. I get 5x is greater than or equal to 6 minus 17 is negative 11. And then to solve for x, I need to just divide everything by a 5. So these will cancel, and I get x is greater than or equal to negative 11 over 5. Okay, so these are my solutions. I get x is less than or equal to negative 23, and it has to be greater than or equal to negative 11 over 5. Okay, so let's go ahead and see where that region interacts. So if we have our number line here, let's kind of look at what we have here. Now I have negative 23, and then on this side I have x is greater than or equal to negative 11 over 5. Now negative 11 over 5 is actually going to be further to the right of negative 23. This is negative 11 over 5. And we know that it says x has to be less than or equal to negative 23. So that's everything over here, right? It has to be to the left. Now this one says x has to be greater than or equal to negative 11 over 5. So it has to include everything over here. But the problem is that with those solutions, they never overlap each other, right? They never touch the same thing. So what that tells us is that there's actually no value of x that would make this statement true. because we have this and here, and this is why it's so important to make sure you say and or, because since we have this and, it actually means we have no solution. So it's very important to check that. So that means that this inequality actually has no solution. So you have to be very careful with these absolute value inequalities, because, and that's why it's so important to kind of graph your answers, is because it's possible that you don't even get a solution to what you're trying to solve for. And so in this case, we didn't, because it's not possible for x to be less than negative 23 and greater than this at the same time, right? That's never possible. So this one was actually no solution. So hopefully I didn't trick you too much there with that one. I said it would be a little bit harder. All right. So that's the end of this video on absolute value inequalities. If you have any questions, feel free to let me know. I'd love to do some more and help you out in the comments if you need it. But if not, then I will see you in the next video. Thanks for watching.